The formulas we're going to use in this section, some of them require logs to solve, some of them are just typed into a calculator as they look, but they're all used to solve problems in finance involving interest. The first example is interest compounded annually. Let's say, for example, you were going to invest $3,200 at an interest rate of 6% for a period of 10 years. For this problem, the amount you end up with is A. The amount you start with is $3,200. That goes in for P. The interest rate is 6%. Make sure you write that as a decimal. And the number of years is 10. You're going to type this line into the graphing calculator exactly like it looks. And the answer, if you'd like to verify it with your own calculator, is $5,730.71. An important part of the lesson, we'll have 4 formulas today, is when reading a problem to be able to figure out which formula you're going to use. The thing that you're going to key into on this formula is it says annually. It's the only formula for annual interest. The rest of the formulas will be asking about payments or about compounded quarterly or compounded yearly or something like that. So this is our only formula for annually. In the next formula, we're going to look at interest compounded a number of times per year. Now remember, our answer to the previous equation, the previous problems was $5,730.70, and that was for interest compounded annually. Let's look at the same example. What if I had $3,200 and I got an interest rate of 6%, but it was compounded quarterly, so 4 times per year, for a period of 10 years. I would type this into the calculator as 3,200 times 1 plus 0.06 over 4 to the 40th power. And if you're looking at this 40 right here, where it comes from is I have 4 times per year times 10 years. So this KT in the formula is the number of compoundings. When I type that into the calculator exactly like it looks, 0.06 divided by 4 to the 40th power, what's really happening is this number is becoming smaller and that number is becoming bigger because I'm doing it 4 times per year, but I'm compounding the interest more times. My solution is $5,804.86. Now, if you think back to the Mary Poppins days, they had banks full of clerks trying to figure out what people's interests were, and it took a lot of time. So a lot of banks tended only to give out interest once per year, or sometimes twice, or sometimes 4 times per year. These days, it's more commonly to compound interest monthly, but that's because we have computers that will run the numbers for us. This formula is for interest compounded continually. In the same example, that would be $3,200 times e to the 0.06 times 10 power. If you type that into the calculator exactly like it looks, you would end up with $5,830.78. Now I feel like I'm kind of leading you on because the problems aren't all this easy. In the majority of the problems on the homework, you'll have to figure out which equation you're going to use, and then you'll have to solve the equation using algebra, and then you'll be able to write the answer, type the answer into your calculator. So in this problem, you want to key into the fact that it says compounded quarterly. The quarterly tells us that we're going to be using the formula that's A equals P times 1 plus R over K to the KT power. For this problem, I'm starting off with $500, so that's my principal. And when I fill this into the problem, it looks like this. $500 times 1 plus 0.078 divided by, now this problem says quarterly. Quarterly means 4 times per year, And so I'm going to put a 4 on the bottom right here, and it's going to be to the 4 times t power, t because I don't actually know how long it will take to double my money. And if you look at the a in the equation, the a is the amount that you end up with. And doubling my money means I'm going to end up with $1,000. And now we're going to go back to the rules for solving equations. If you're solving an equation that has an exponent or a log, your first step is to isolate the exponential part. So we're going to look at this piece right here. We're going to have to isolate this piece, and that means we're going to have to get rid of the 500. I divide both sides by 500, I end up with 2 equals 1 plus 0.078 divided by 4. That's 1 plus 0.0195 to the 4t power. And it might make it easier for you to think about it if you wrote that as 1.0195 to the 4t power. Now at this point, you can choose to log both sides, or you can choose to convert this problem into a log and use the change of base rule. I prefer it to do the second way, so I'm going to write this as log base 1.0195 of 2 is equal to 4t. Now how I type that into the calculator is with the change of base rule. And so I'm going to type it on the calculator, log of 2 divided by log of 1.0195. I'm going to hit enter, and then I'm going to divide that by 4 because I still have to eliminate the 4 that's right here on the right hand side of an equation. And so log of 2 divided by the log of 1.0195 divided by 4 is 8.97, and that means you would expect to take about 9 years to double your money if you invested at a quarterly, if you invested it compounded quarterly at 7.8%. In order to keep my video down, I'm going to have to cut out the last example, and so we'll do it in class first thing next class. This problem is about the future value of annuity. That would be like if your parents had saved money for you for college. Like let's say they started off with a modest amount, $50 a month at 7% interest, which is actually pretty doable even in today's economy if you go long term and you're investing it in the stock market. And they did that for 18 years. So for this problem, to find the future value, like how much your college fund would have in it, we're going to take $50 a month times 1 plus, and in this problem, this I for interest rate is the interest rate per compounding period. And so if I figure out the interest, like if I'm putting away money monthly in this case, this is going to be 0.07 over 12. So 1 plus 0.07 over 12. And now if you're looking right here at the number of payments, well, they're making 12 payments per year for 18 years. And 18 times 12 is 216. And that's divided by the 0.07 over 12. You type this into the calculator just like it looks, with a few extra parentheses tossed in for good measure, like right there. And that would be a whopping $30,107.47. Now it's interesting, if you actually just took 50, 12 times a year for 18 years, multiply those all numbers all together, you'd have about $10,000. But accrued interest, you've got $30,000, and it's doable. So if you didn't have parents that were able to do that for you, maybe you can think about doing it for your own children. Just pause on this slide to write down what everything stands for the present value of an annuity. And remember, these formulas will be on the board. It's just that you have to know that I stands for like the interest rate per compounding period. So like if I were to do it 12 times per year, I would be the interest rate divided by 12. And the N is the number of payments. So if I made 12 payments a year for 5 years, N would be 60. And as long as you remember those two things, it's really a matter of copying down the formula, plugging the numbers in, getting the answer. You would use this kind of a problem if you're trying to figure out the payment. For example, if you were buying yourself a new truck and you wanted to figure out what the payment is for a 6-year loan versus a 5-year loan, that kind of thing.